Okay, so we're recording. This month we're going to talk about automated testing with CMake, CTest, and CDash. So CTest is another application that is provided in the CMake suite that runs your tests, gathers up test results, and sends it off to a web-based dashboard. And that web-based dashboard is CDash. So it's really pretty simple in terms of what you need to adjust your CMake build scripts to adjust this to support running tests. We'll look at that first, and then we'll look at running tests with CTest, and then we'll take a look at what a dashboard looks like in CDash and how CDash organizes things. So really, a test in CMake is just a command. That command can be running an executable that was built by CMake. It can be running some kind of script. It can be anything that is expressed as a command. So this is in contrast to Google Test, where a test is essentially a class that has a body, a test body that is executed as part of a test case. And so within a Google test executable, there are many test cases. Whereas in CMake, every test case is a single command. So it's typically, a single executable. And tests are considered to pass when typically the one you would use most often is when the return code of the process is 0. But you can also have pass-fail conditions based on the output of the test, according to regexes. So to enable all this, you need to call enable testing in your CMake list somewhere, and we'll see why, but it is recommended that this be after you declare your project, so at your top level CMake lists. And you call add test to add each test case as a command to be executed. So, and enable testing takes no arguments, so you just call it, then that just gets the testing framework set up. You add a test. Each test has a name. This name is merely a place to hang properties. If you recall back to when we looked at libraries and targets and everything inside CMake, it was all orchestrated and configured through properties associated with targets. So here, you have to have a name to hang the properties off of, and that's what the test name is. Otherwise, the test name, other than following CMake identifier conventions, so it has to begin with a letter. It can only contain letters, underscores, digits. It can't contain spaces or any other, special characters. Other than that, the name is just used as a way for you to organize your tests with some meaningful name, and those names flow through into the dashboard. But other than that, it's just a name. You give it a command, which has to have obviously some executable to run as that command, and you can have optional arguments. The command, if it references the name of a target that is built by CMake, then CMake will substitute the full absolute path to that target as it is built, so you don't need to do that. The configurations, can be useful if you have, say, some tests that should only be run in a debug configuration or in a specific configuration. You can narrow the test to those particular configurations. Working directory for where the command will be launched from. And then this command expand lists, we'll see how that interacts in just a second here. So as I said, the command can be a CMake target, and you don't have to have a one-to-one correspondence between the test name and the command. So, for instance, you can run the same executable with differing arguments as different test cases that are added. So just because you have multiple tests, doesn't mean that they all have to run different executables. They don't even have to run different commands, although it would be silly for you to have two different test cases that run the same command. Now the command line arguments can use generator expressions. So this you can use special arguments, for instance, if it's a debug configuration only. And that command expand lists is an option that you want to use to add test if for any reason one of your generator expressions could result in an empty string. Because what you want to have happen in that case is you don't want to pass an empty command line argument if your generator expression results in an empty string. You just want to have that argument essentially omitted. So if you use that command expand lists, if that is the case. Otherwise, you can just use generator expressions. And if they always generate an argument, then you don't need to use the expand lists option. You do want to be careful to use absolute paths if you're specifying the working directory, because if you specify a relative path, it's relative to where CTest is running from, which may not give you what you expect. So it's just best to use absolute paths for the working directory if you specify it. Why would you need to specify the working directory? Suppose your test is going to read some data files, and you have different sets of data files in different directories. You would you can run the same executable, the same command, but in different working directories to have it process the different sets of data files that reside in those directories. So that might be an example of why you would want to use the working directory. Another way to solve that problem would be to specify command line arguments and specify CMake current source dir, or whatever the absolute path to your data files as command line arguments. But suppose you just didn't want to process command line arguments, you just want to assume the input file exists relative to the current directory. You can deal with that with the working directory. If it's one or two files, you might do it with command line arguments. If it's a bunch of different files, specifying long argument lists is annoying, so you might want to do that with the working directory setting instead. And just like everything else in CMake, tests are configured through a set of properties. You can either use the set property form with the test keyword, and that form is useful for setting properties that take lists of values, because you don't have to worry about formatting the lists of values as a semicolon separated string. So just to refresh your memory, in CMake, everything that is a list is really just a string where the values in the list are separated in the string value by semicolons. So if you have a property that has a list of values, it can be easier to write that in your CMake script by using the set property form. Set tests properties allows you to set multiple properties for multiple tests all in one command, but the values are single values. So if you're setting a list of values, then you have to make sure that that is formatted as a string where the values are separated by semicolons inside the string. And just take note that it's set tests properties because you can set the properties for multiple tests, although typically you do this for one test at a time. But just make sure you notice that, because for instance, the convenience commands for setting properties on a target is set target properties. The target is singular, so just keep an eye on that. Common test properties that you might use, there's a bunch of properties that control what happens when the tests are run, and there's some properties that control whether or not the tests are considered successful, and there's also this labels property that it can be used to organize tests into groups. And we'll take a look at these in more detail as we go on. So configure the test result. You might have a test, for instance, where the purpose of running it is to guarantee that a certain thing does not work. In other words, you're going to run some command and it, for instance, a command that scans through your executable looking for strings that shouldn't appear. Like you don't want internal names to leak out in your test executable as string text. So you would grep the executable for the offending text, and the grep should fail. So you can set the will fail property. It's a Boolean value. And if you set that to true, then if the grep does not find the text, then the test is considered to have passed. So that can be handy because otherwise you would have to wrap up the grep in another script and then test for success yourself and then invert it to make sure that you're saying if the grep failed, then the test was successful. Otherwise, if the grep succeeded, then the test failed. So it's handy for those kinds of tests. Skip return code, you can have your test executable, perhaps it needs, for instance, I work at NVIDIA. We write lots of tests that run on GPUs. There are some tests that only make sense if you have multiple GPUs. So we can probe the environment, determine, oh, you don't have multiple GPUs, therefore this test should be skipped. So that text executable could return whatever the value is that is set by this property, and then CTest would record it as a skip, not as a failure. So that can be useful. And then you've got regular expressions that can be used on the output of the test to determine whether the test passed, failed, or was skipped. And the precedence is, I believe, that if the output matches the fail regular expression, the test is considered to have failed. If it then matches the skip regular expression, the test will be skipped. And then otherwise, if it matches the pass regular expression, it will be considered to have passed. And if none of them match, then I believe it will use the return code of the process. There might be some subtle differences in reality between what I just said and the documentation, so always use the documentation as the final arbiter and not what I'm saying. Although, I mean, obviously, I looked this stuff up, but I could be wrong on some details, so it's always best to rely on the documentation as the final word. Labels just gives you a way to place tests in groups to give you an easy way to say, run this set of tests. A very common thing for developers to have is a set of quick tests that are regarded as a quick thumbs up, thumbs down, often called a smoke test. And you want to, you run those as part of every commit, every check-in. And then there's a, more lengthy, more exhaustive test suite that's run, on a nightly build, for instance. So you could add a smoke label to your test cases that are the ones that every developer should be running at their desk. And then the full suite would be run by a nightly build, or whatever other organizations of your tests you might consider useful. Unlike a lot of testing frameworks, CTest doesn't give you a way to organize your tests into any sort of hierarchy. So if you want to group your tests, because you have a lot of them, then you'll want to use labels to serve that purpose. You can construct labels in such a way that they represent a hierarchy, but it's just really just a set mechanism. Sometimes you have dependencies between tests. You might need another test to run first. Usually you want all your tests to be able to be run independently of each other and have no order dependencies, but sometimes it's just easier to set things up so that have one test run before another one. You can do this with a depends property. It only controls the order of the test execution. If test A depends on test B, it just says B will run first. If B fails, it will still run A. It does not act as a gating factor, it just acts as an ordering. If you do need a gating factor, then CTest provides a thing they call test fixtures. And in this case, a fixture is just a name that is used to coordinate how setup, teardown, and test execution is managed between a set of tests. If you put a fixtures setup property on a test, then that command, remember tests are just commands, so that command is considered to be a setup command for any test using the fixture. If the setup fails, any tests that require the fixture will not be run because the setup could not guarantee the initial conditions. And then the fixtures cleanup property is what you attach to a command to do any tear down or cleanup. Usually it's the reverse of the setup operation that you've done. So if we look at an example here, some tests might require a server to be running in the test environment, or they might require a database. So we've got a setup test called start server. This is running whatever command it takes to launch the server and get it running. We've got a cleanup stop server test. This is running the reverse command that stops whatever the service is. We've got a database up test that just probes to see if the database is available. And then we have a client NoDB test that needs the server, but it doesn't need the database. So its fixtures required property is set to server. And then we have a client test that needs both the server and the database. So its fixtures required contains both server and database. And there you see an example of a CMake list being set. It's two values separated by semicolon as a string. So if the server doesn't start, then neither of these tests, client NoDB and client, neither of those will run because the necessary precondition couldn't be established. If the server could start, but the database wasn't available, then client NoDB would run, but client would not, because client needs both the server and the database. So I don't know about you guys, but when I've done testing before and you've got elaborate integration scenarios that you need to orchestrate, you need all this stuff working together. In the past, we've just kind of cobbled things up together with weird Jenkins workflows or, handwritten scripts that try to get all this stuff orchestrated. And I find this, the CTest fixture mechanism to be a little more straightforward and manageable. So what does CTest actually do? Well, when you call enable testing, that establishes the location of a CMake script in your build directory that corresponds to the location of where the enable testing was called. So this is why the recommendation for calling enable testing is to do it in your topmost level CMake script where your project is defined. And when you call add test, this is just writing commands to that CMake script. So when you configure your CMake build, enable testing will establish the location of the CTest script. Add test will scribble additional commands into that script. And after your build is all configured and it's the configuration step is finished, you will have a CTest script that represents all the commands necessary to run all the tests that have been described by your build. If you modify your CMake lists and CMake reconfigures, that script will be regenerated. So anytime you modify a CMake list to add a new test, you run your build will notice that your CMake list has changed. It will reconfigure and regenerate the test script, and then your test script is up to date. And normally, if you're just running the tests manually, you can just run those tests by putting your current directory over to the corresponding build directory, the top level build directory, and then running CTest, and it will find that script and run it. When you use an IDE, well, all the generators support a special target that you can use from your build to run the tests as well. It just runs CTest. So in a makefile style generator, that just creates a target called test. So you could say make test, and it'll run CTest for you by switching to that top level directory and then running CTest. In an IDE like Xcode or Visual Studio, there will be a special target called run_tests that you can either invoke from the command line or you can invoke it from the IDE, and it just runs CTest. So CTest is just an executable like CMake, and it has command line arguments. And again, as we've discussed before, everything with CMake ships with all of the documentation that is online for the version of, obviously the documentation that you have installed locally will be corresponding to the version of CMake that you have. But CTest is not a separate thing that you need to download. It is included with CMake. So if you have CMake, you have CTest already as an executable. So you can look at the local help or look at the website help that's out there for any of these details, but this is just a summary. There's many possible command line arguments to CTest, as you might imagine. These are some that you might need. If you're using a multi-configuration project generator like Visual Studio, then when you run CTest, you'll want to tell it the configuration that you want it to run, because if you haven't built the release configuration, then the test executables for a release configuration won't exist. Only if those test executables are targets that are built by CMake. If they're just ordinary script commands, then it won't matter, right? But ultimately, you're going to want to test the C++ code that you're building. So if you haven't built it for a release configuration and you tell CTest to run the tests for the release configuration, it'll most likely just complain like, I couldn't find this executable. So if you get that error, that's a thing to check. You can specify regexes for tests to run and tests to exclude, and these are just matching the test names. So you might imagine that as those names are arbitrary, if you want to arrange the tests in a hierarchy, you might have the hierarchy consisting of a bunch of names that are separated by underscores, and you can use the regexes to match against that naming convention to specify portions of your test cases, to run or to exclude. As mentioned, you can also use the labels with a regex matching labels to select tests to run. You can combine that with the -e regex to specify some tests to exclude, to do kind of include and exclude lists. Tests that take a long time, you might want to consider them to have failed if they take longer than a certain amount of time. So you've got the --timeout option to be able to specify that. Stop time is interesting. This is an argument which most likely you wouldn't use from the command line when you're invoking CTest manually, but if you're invoking CTest from some kind of automated system, you might say, we don't want, say we've got a continuous integration machine, and that machine is running tests at night when people aren't working, and then when they come in the morning, we don't want the continuous integration machine to be bogged down running tests. We want it to be doing incremental builds, continuous integration builds. So you can use the stop time argument to say, if we're still running when we reach this time of day, then we should just stop so that we don't run on into the busy portion of the day. You've got the -j argument for specifying parallel execution of tests. And there's a resource spec file argument. We'll see how that comes into play with describing available resources and resource constraints for tests later on. It's fairly involved. I won't go into all the details of it, but if you need to specify that, that's how you would do that. So resource constraints. When you're running different test cases, they might need lots of CPU, or they might need lots of RAM. They might need lots of GPU. You don't want these tests failing simply because when you're running your tests in parallel, you ran it with this CPU-hungry test in parallel with a bunch of other tests. Because those other tests are also using CPU, now suddenly this CPU-hungry test exceeded its timeout value and started failing. And then you run it in isolation, run that test by itself, and it never times out. Similarly, you've got tests that might need lots of RAM. This could cause other tests to start failing because they exhaust virtual memory, and then they start failing because they can't allocate memory. And then you run them in isolation by themselves, and then they always pass. Or they might be competing for GPU resources. So it's annoying to have false failures because you get this failure report, you go and investigate it, you spend half a day or whatever trying to figure out why it failed, and then it's only after a while you realize, like, oh, it actually was just resource starvation. It's not actually an error in functionality. So the most heavy-handed way that you can deal with this is to put the run serial property, which is a Boolean property. You can force a test to run alone. And that might solve your problem, but now you're not getting the most amount of parallelism out of your test machine. And as you add more and more tests, running them all sequentially isn't really going to be a viable option. So the next finer grained way of controlling how tests compete with each other is you can say, well, this test needs this server, and the other tests, there's a handful of tests that need this server, and the rest of the tests don't need the server. So we can say, we're going to name a resource that represents the server, and we're going to say all these tests that need the server, we're going to run them sequentially, but they can run in parallel with any other test. So you are essentially declaring a named resource and saying each test that depends on that resource is executing sequentially, but any test that doesn't need the resource can execute concurrently. So that's a little better than just saying, no other test can run while this test is running. It's saying any other test that needs this resource can't be running. And a test could, through the resource lock property, this could be a list of named resources. However, that's still pretty restrictive. That you can get finer grained control using the resource groups property. This lets you specify the quantity of each resource that a test needs. And a test can say, I need different quantities of different resources. So I need this much, and the resources are just arbitrarily named, and the quantities are arbitrary, but they are integers. So for instance, you might say, you might create a resource that represents the number of megabytes that a test needs. And so you say, well, my machine has this much physical RAM that I'm running the tests on. It has, 4 gigabytes of RAM. So this one test needs, 1 gigabyte. This other one needs 2 gigabytes. And then I have a third test that needs 3 gigabytes. So obviously, if I've got 4 gigabytes of physical RAM, and that's what I'm specifying as my resource limit, I can run 2 instances of a 2 gigabyte test concurrently, or I can run a 3 gigabyte test and a 1 gigabyte test concurrently, but I won't run the 3 gigabyte and the 2 gigabyte test concurrently. So you specify resource groups, which are again just names, and there's a configuration file that's just a JSON file where you set up the possible resource combinations that are available to a test, and then using the resource groups property, you specify the resource needs of each individual test, and CTest will schedule the tests in such a way that no resource is exhausted. And as you can imagine, this can get pretty complicated just in terms of how you want to describe different configurations, and the full details of that are in the documentation, and it can be handy, but it's fairly complex. So just in terms of all the little details, it's not complex in the sense that it's not difficult to understand or implement. But I could spend 20 minutes talking about it. So we're just gonna give it this summary description, and we'll go on to the next thing. There is also support for Google Test in the sense that if you are using Google Test, it might be nice to track each individual Google test case as a CTest test case. Now, you could do this manually by adding each individual Google test case as a command to run the corresponding test executable. And Google Test has a way of filtering test cases by using the, I believe it's gtest_filter command line argument. And you specify, they have a wildcard matching scheme for specifying test cases, but if you wanted it to be one-to-one, then each add test would use a gtest filter that would specify exactly one Google test case. So this would result in a CTest test case that launches the test executable once for every test case in the test executable. Why would you want to do that? Sounds like a lot of work. Well, you want to do that as a way of getting finer grained tracking on success and failure of tests. So if I have 1,000 test cases in a single Google test executable, and I just invoke it as a single CTest test case, the entire thing will be considered failed if any one of the individual Google test cases fail. So there's 1,000 different ways that this CTest test case could fail. So my dashboard is just saying like failed forever. And it's not giving me feedback on exactly what it is that's failing until I have to manually drill down into the Google test output to see which test cases are failing. So if I track all those Google test cases as individual CTest test cases, I can see like, oh, most of them are passing, but this one, there's a small set of handful of tests that are flipping between passing and succeeding, and it's, although I never get in the aggregate a pass result, I can see that it's actually just a few test cases that are flip-flopping back and forth. And that lets me focus in on the test cases that matter. However, it's really tedious to have to go and add all those test cases by hand if I have many of them. So in CMake 3.9, they had a command called gtest, or they have a command called gtest add tests. And what this does is you give it a target. That's how it knows which test executable to run when it adds the CTest test case. And you give it a set of source files. And what it does is it basically greps over your source files looking for the things that it recognizes that add Google test cases from your source. And from there, it scrapes out and deduces the name of the test case and uses it to add a CTest test case that is named after your Google test case, and the test prefix and test suffix optional arguments are just text that is prepended and appended to the Google test case name that it got out of your source files. The extra args are any extra command line arguments that need to be passed to your test executable, because in Google Test, it provides an implementation of main, but you can write your own, so you can do extra command line processing in the working directory, obviously. And then if you want to get the list of CTest test names that were created by grepping through your source files, you can get that into a variable with the test list argument. Now, that's pretty convenient. However, it means every time your source files change, it reruns this grep. And if you have a large set of tests, then rerunning this grep every time those source file changes, that can be annoying to your build. So As I said, this scans all your source files to identify the tests, adds one CTest test cases for every Google test case, and you can get a variable name that will have all the test cases that were added in CTest. Unfortunately, it misses parameterized tests. Parameterized tests in Google Test give you a way to say, I have a bunch of data values. I want you to run this test over and over again, supplying the data values as a parameter to the test. If you wrote any custom macros for defining your own tests in Google Test, then it would miss that too. Why would you write custom macros? For instance, you might say, I have some tests that access an internal data structure that's only available in a developer build, and that data structure is not available in a release build, so I only want to add these tests in Google Test if I'm building a developer build. So you won't get those tests either. So in 3.10, they recognized that that was kind of, less than ideal. And what they added was, in Google Test, you can run a test executable with a command line argument and ask the test executable itself to list out all of the test cases. And that will include the parameterized tests. So CTest Discover tests works in this fashion, that it adds some commands to the script that is used when CTest is run. So the CMake script that is input to CTest to run the target executable, dump out all the test names, and then create CTest test cases corresponding to all those test names. And it would, again, use the supplied prefix and suffix to create those test names. Now, when you run Google Test in this mode and ask it to print out the list of the test cases have the parameter values listed as part of the, they can either list, fancy text that is a human readable form of the parameter value as part of the test case name, or they will print out just the index into the set of values that's used by the parameterized test as part of the test case name. So there's the no pretty types and no pretty values options that allow you to influence the way CTest will create the test case name from the listed name provided by Google Test. You might need to do that if your pretty printer is resulting in either test case names after they've been sanitized that in CTest they're no longer unique, or they're just, it's not useful to have that pretty printed value. You might want to just use the regular index. And because this is running at the time that CTest is run, this test list output variable, it means that that variable is populated as CTest is processing the script that it is running. It is not available to your CMake build at the time that you're configuring this business. And if your test executable has some very large number of tests in it, you might need to use the discovery timeout value. So, as we're saying, it runs a test executable, get the test name, and the test names aren't available until you run CTest, which means if you want to further configure the test cases in your CMake script, you can't do that at CMake configuration time. There's a way to do it by writing an additional handwritten file that gets slurped into the CTest script, and you can find that in the CMake documentation and the CTest documentation. So it's not like it's impossible to do if you need to do some additional customization via properties on the tests, but you have to do a little extra work if you need that. So that's CTest, and you don't have to use the CDash dashboard with CTest. You could run CTest, get your test results. You can inspect those test results manually. There's also plugins for Jenkins, that, for instance, that will consume the CTest output and allow you to visualize and browse that test result data in Jenkins. But CDash is also available. It's what Kitware uses for all of their projects. And it's a web-based dashboard for test results and trends, and it's free and open source. And CTest can prepare results for submission to CDash. Normally, you run CDash on, some server machine because it's going to be a long-running web server process. It's typically not going to run it on your developer machine. You're going to run it on some machine on your local network so that you can use it to share test trend data between everybody on your team. CDash organizes data from pipeline steps according to models, and the models are displayed in tracks on the dashboard. There's a little snapshot of what the dashboard looks like. This is a snapshot a little screenshot that I grabbed from CMake's dashboard. We'll take a look at these pieces here. The track is just used to organize the display of the data on the dashboard. So it's typically just a human readable name. Here they've got a continuous track. They have a bunch of different tracks. Each step is shown as a column, and the builds are rows within this table. So within the table, you've got, there's an update step that's going out and getting, the latest version of the software. They're using Git at Kitware, so the revision column holds a little short Git hash representing the revision that was used for the build. There's the configure step, that's the CMake configure step. For a continuous build, you wouldn't necessarily have anything interesting going on in the configure step unless you changed your CMake list.txt. So it updated from source control. Typically in a continuous integration build, you're updating and doing incremental updates. You're not checking out the entire source tree fresh. So the configure step only does something when you've touched one of your CMake files. Then there's a build step, which is, again, in an incremental build. It's just compiling any source files that have changed and not recompiling everything. And then the test step is the results of running CTest. And there's some other steps that you can optionally have. We'll see those in a second. So here's are the steps that CTest knows about. There's the start step, which is really just a way for CTest to tell CDash, like, okay, I'm beginning the execution of some pipeline, so that CDash will have a way of understanding you started at this time, you ended at the end on your submit, and I can compute the total time it took for the pipeline to execute by looking at the timestamps between the two. The update step is getting any source code from version control. The configure step is doing the CMake configure operation. There's the build. There's running the tests. You may have a coverage step that's measuring code coverage. It's typically done with gcov, although it can be configured to use an arbitrary command. There's a memcheck, optional memcheck step that is used to run things like valgrind or the sanitizers that are available in GCC and Clang. So we've got like address sanitizer, memory sanitizer, thread sanitizer, undefined behavior sanitizer. The coverage and memcheck steps are not enabled by default in a pipeline, but when they are run, they always display their results in a specially named track. It's the coverage track for the coverage analysis and the dynamic analysis track for the memcheck step. The submit check at the end is where CTest pushes up all of the data to the CDash server. So every pipeline is associated with a model, And the model defines the default steps and the error behavior. And there are 3 models that CDash understands. There's a nightly, continuous, and experimental. And these are the default configurations of these models. You can configure them, obviously, in these default configurations, the memcheck steps are not run in any of them. So if you want to do the memcheck, obviously you have to have some way to configure it so you change it from the default configuration. But your nightly model is basically for a standard kind of nightly builds. It's going to do everything except memcheck, and it will continue to execute if the update step fails. So the idea is you have a copy of the source code already. So if you do an update and you try to get incremental updates and for whatever reason that didn't come down, you just use last night's copy of the code and rebuild everything again. Continuous is meant for continuous integration kind of builds where if the update fails, you don't want to continue and do anything because the whole point was to get the new changes from version control and try and build them and make sure that everything runs. So if you couldn't get something from version control, that indicates you've got a problem, so you want that to fail. Or you don't want it to proceed, is I guess probably a more correct way of saying it. And the experimental model is a place for you to include all kinds of interesting experiments that you might want to do, but you don't want to interfere with continuous or nightly builds just to try out an experiment. And by default, that excludes the update and the memcheck steps. So you can use CTest to execute a particular model or a particular step. And really all this does is under the covers, it's just running commands in the CMake script that is generated for CTest by your CMake configure step. And you have to at least specify a model or a step. And it would be very common, for instance, on a continuous integration machine to just say, run the continuous model. You just do all the steps that are configured for that. Or for your nightly build machine to just say, run the nightly model and just do all the steps that are configured for that. You can have the results sent to a specific track by using the track argument. And you need a CDash configuration in place in order to do this. And we'll look at that configuration in a little bit. So for instance, you can run CTest and run the nightly model and say, put that out to the nightly master track. Now, the CDash configuration is mostly handled by a module that is shipped with CMake called the CTest module. And you would include that typically after your project has been defined. And that module will define a build testing variable. And this will let you adjust your CMake script so that, for instance, maybe you don't want to add a whole bunch of tests to a developer workflow, to have all that stuff created and managed by CMake and by CTest at a developer's workspace. So you can say if build testing is off, we won't add those tests. We won't call add test. And the CTest module calls enable testing for you so that you just include CTest and that should be enough. And that will call enable testing for you and then set this build testing property. You can use that to define whether or not you're going to add test cases to your build in the configure step. This requires a CTest config.cmake at the top level of your tree. And this is what configures the connection to the CDash dashboard. Here's an example. You need a project name for use by CTest, and that's what CDash is going to use to refer to the project. CDash CDash likes to organize things by showing trends day by day, and it has to know when the day is considered to have started. So this nightly start time is what CDash will use to say, oh, if it's after 1 a.m. Universal Time, then that will be considered, the beginning of the day. And then there's the CTest drop properties, variables that are used to configure the different pieces of the submission URL, essentially. And CTest used launchers, which is just handy to have the command lines appear in the logs on CDash. So when you see that a test case failed, you can see the command line for that test case as it was written out. Now in 3.14, they simplified it so you can just say, here's the submit URL that's used by CTest when it submits the data up to the CDash server. So if you're using 3.14 or later, that configuration just gets a lot simpler. The drop properties could still be used, so it's not like you have to switch if you were using this old form, but if you're using 3.14 or later and you're creating this, you might as well just use the submit URL form because it's just easier to read and see what's going on. Now, it's also possible to, we saw earlier that you can run a pipeline by specifying the model, and you can run the individual steps by specifying the steps with -t, specifying the model with -m. But you can also create a custom pipeline that does whatever you want by invoking the CTest commands directly. And you can invoke that script with CTest-S. And it's just a CMake script, but it gives you finer control over the individual steps. And one reason you might want to do that is so that, for instance, when you just say run the model, say like run the nightly model, it'll run all the steps and do the submit at the end. If you create a custom pipeline script, you can submit the partial results for each individual step after that step has completed. So you do the update, you can submit the results of the update up to CDash. You can do the build, you can do the configure step, submit the results of the configure step up. You can do the build, submit the results of the build. Then you can run the test, submit the results of the test. And if you do that, it allows CDash to display incremental progress as the job is running. You can see, here's all the files that it updated in the update step. Here's the result of the configuration. Here's the result of the build. And you can see all that while the tests are running. If you need that fine level of control, you can get it. It also allows you to attach arbitrary payloads to the final results submitted up to CDash. For instance, again, I work at NVIDIA. We do graphics. So a lot of our tests have programs we run and we compare the resulting render against a gold image. And it's useful to have those images included with the test results, because if the test fails, sometimes it's just like, oh, the image is wrong. So a custom pipeline execution would let you attach all these extra payloads or extra directories, whatever you need to include, send that up to the CDash server. It's also possible for a particular test case to just set some properties, the attached files and attached files on fail properties. You can set those if that's all you need. If all you need is just some extra files to be included with the test, that might be an easier way to go. And when the upload or submit step is run as part of the pipeline, those will be included for that test case. There's also a measurement property that allows you to specify a single value that can be tracked for that test in CDash. It's a little weird, the measurement property, because if you think about it, you specify properties on a test at CMake configure time. So the test hasn't run yet, In fact, the test probably hasn't even been built yet if it's running a test executable that you've written in C++. So the value that's associated with the measurement, it's really only useful if it's something that is varying at configure time. So that doesn't sound, it sounds like it would be handy, but it's when you think about how it actually works, it can't get data out of the test. However, CTest snoops the test output for XML fragments that can be used to define measurements. So you can use this to report little name value pairs out of the test output. The details of that are in the documentation, but if you need to track a trend of measurements that can only be obtained by running the test, say it's a performance measurement, or it is whatever, any other kind of measurement that you want to track as a trend over time, you might want to have your command run a test executable that is set up to output these XML fragments, and they'll be scraped up by CTest and included in the test results that are populated in CDash. Another option is to simply create a wrapper around some, may not be feasible to instrument an existing executable to put out these little fragments, even though the executable somehow reports some kind of measure that you want to track. So you can wrap that executable in a script or some other executable that runs it, and then have that wrapper output little XML. As always in software engineering, every problem is solved by another layer of indirection. So, and again, the documentation has an explanation of what the XML needs to look like and the different kinds of values that can be tracked. So if you need to do that, consult the documentation for that details. If you want to dig further into this stuff, the CMake, CTest, and CDash documentation is good for reference, but if you're trying to piece it together in terms of practical advice and hard-won experience, I would definitely recommend looking at Professional CMake, a practical guide by Craig Scott. This is where I learned a lot of this stuff from. I find his book, it's only available as an electronic book, so you can't get a Dead Tree edition as far as I know. But that's the only downside to it. Being an electronic book, he continues to update it with feedback from viewers. It's really comprehensive and really well written, and he's got a lot of great information about practical things to do with CTest. Let's take a look at the CMake dashboard. So his book is a great place to look for lots of practical advice. So here we are looking at the CDash dashboard for CMake. And here we can see they've got different tracks. Here's a scan build track. Here's a nightly expected track, a master track, continuous track. This is their continuous integration track. Continuous help. I believe this is what's building all the built-in help documentation that ships with CMake. Here's their nightly track, an experimental track. You can see they've got, tests that are failing on their experimental track. Here's their coverage analysis track. You can see they've got pretty good test coverage for their code, 75 to 80%. Anything between 70 and 80% I would consider to be very good for a C++ project. We've got a dynamic analysis track. They've got two builds, one doing Valgrind and one doing address sanitizer. And these things are all, like a lot of web dashboards, you can drill into any of these things. So all of these things are hyperlinks. So there's no errors. We can go look at this one failure, for instance. So it's telling us that test console buff failed. It ran in 11.9 seconds. Here's a summary link. This is all that looks like this is all the summary for this particular test. It's been passing on most jobs and only failed recently. If we drill into this, I believe this will show us the details of the test. Here's the test output. Failed with error 0. Wait for single object number 2 failed. So this looks like some kind of wait for single object is a Windows synchronization primitive. We can start browsing into the repository and so on. That's the nice thing about web dashboards. If you do it correctly, everything is highly cross-linked, so you can drill into the data 6 ways from Sunday, which is exactly what you want for a dashboard. There's no single way that you want to drill into things when stuff fails. You want to be able to have lots of flexibility to drill in on many different dimensions of all these axes that control what the end result is. So CDash itself, if we just go to cdash.org, it is available as a free download. And it's PHP based, so you will need some kind of PHP based web server. Uses MySQL for the database, so fairly standard for a Linux oriented web application. MySQL plus PHP. Looks like it's got a few other little requirements for PHP modules that you have to have installed. Now, I haven't drilled into it to confirm this, but I believe that if you have an open source project, you could get them to host the dashboard. Not 100% certain about that, but I believe that might be the case. So yeah, they're hosting CDash dashboards for all of these open source projects. So, boost asynchronous file I/O, boost outcome. I saw a JPEG down here. Open JPEG. So if you're doing an open source project, it looks to me like now they're not hosting the test farm. You're running the test farm. They're just hosting the CDash database and they're running an instance of CDash that's showing your project. So I don't know how you would go and get your project listed on their open source dashboard, but it's not really a barrier because you can download CDash yourself and host your own dashboard. So that's all we got to say about CTest and CDash. If we have any questions, we can see if we can answer those. And if you're going to ask a question, remember to unmute your microphone first. Charles?
I don't have any questions, but it's like very nice. It was really cool. I like that. And it was really nice, neat looking at the way how you could drill through the data in the different ways. And
yeah, I would say if you're considering using this, go out to the existing open source projects that are using the dashboard and see if it, looks like it's going to satisfy your needs before you have to download and install and configure anything.
True. But very cool. Very neat.
Any other questions, Caleb?
Yeah, I have a quick question. You were talking about having multiple GPU environments where some tests would just skip. How do you go about setting something like that? I didn't see anything like environment variables that you just pass through CMake or something to be able to get that done. Or maybe I missed it.
It's back here. Okay, so there's a skip return code. So for instance, if let's take the multi-GPU case. You have your test executable, probe the environment, and if there's less than the number of GPUs that it needs, then the process can return that error code, this whatever the value of this property is. So you just have to coordinate. In your CMake list, you would say skip return code for this test is 2. And then in your test executable, you probe the environment, and if the requirements aren't there, you just say exit 2.
Gotcha.
Then that
Yeah,
test
that
could be
makes
skipped.
sense.
The other option is you can output some text and set the skip regular expression. I'm missing an underscore here, but the property is skip underscore regular underscore expression. And if that regular expression matches the test output, CTest will skip the test. Those are the 2 ways that you can do it.
Gotcha. What if you wanted to send something like you had a test that ran dynamically with a number of let's say GPUs or something like that? Like you said, this can run with n GPUs, but I expect a different result or something based on that. So like, is there a way to pass parameterized information through CTest to the test?
Yes, when you let's go back here. When you call add test, you can supply arguments to the command, and those arguments can use generator expressions. So you can, using CTest. Now, the only information you can vary on those command lines is information that you've determined at CMake configure time. So
Gotcha.
if you do a CMake configure, you can probe the environment to your heart's content. You can run arbitrary code, get arbitrary values. You can look at environment variables. You can look at CMake variables that are options that have been set on the command line or set through CMake GUI. Anything that feeds into the configuration process you can use to either set CMake variables or use as in combination with generator expressions to get whatever you want to pass in as a command line argument. Now, it may not be dynamic enough in the sense that it's only evaluated at CMake configure time. And if you need something more dynamic, then I would use the skip return code or the skip regular expression and have your test your test executable do the probing of the environment and determine if it should be skipped or not. Now, and again, like for instance, maybe you have to run a customer binary as a regression test. That customer binary obviously doesn't know anything about skip return codes or skip regular expressions. So sometimes you just have to wrap up executing that customer binary in another binary or another script and have that script understand how to communicate with CTest or that binary, the wrapper basically.
Gotcha. Yeah, thanks so much. Yeah, this is great.
Any other questions, or are we ready to wrap up? Okay, I am going to stop this recording.